Engineering 305, problem chapter 2, number 46. At a point on a stressed body, there are normal stresses of 95 megapascals in tension on a vertical plane and 125 megapascals in tension on a horizontal plane, as shown in figure 246. Okay, first thing we should, well, if you've done the rest of the chapter, you should recognize that those are the principal stresses, right? There are no shear stresses. So go and determine the normal and shear stresses at this point on the inclined plane AB shown in the figure. All right? I am going to rewrite our problem. So problem 246, I've got 125 megapascals, 125. I'm going to drop the units. It could be in PSI if you feel more comfortable. That's 95. And now I got to draw this angle right. Okay, 20 degrees like that. Yep, got it. That angle, that's my cutting plane right there, and that's 20 degrees. So what's the vector look like? What's the vector look like for the surface that I'm interested in? Let me draw these other arrows on here just for clarity. This is the normal vector to that surface. I could draw it there, or I could draw it this way. Right? And so if I look at that, then the angle, then if I draw my triad over here, or my coordinate system over here, there's my X, there's my Y. That's N. And that angle is minus 70 degrees. Yeah. We would have gotten that mixed up. There's T. And then I'm telling you, I like to put these down. Sigma X is equal to 95. It's positive. Sigma Y is equal to 125. Tau XY is equal to 0. All right. Sorry, I don't even remember the question anymore. That's just writing out the problem or parts of the problem. Determine the normal and shear stresses. Right. Determine the normal and shear stresses. So I've got to write down an equation for the normal stress and the shear stress. And do you remember what those are? Of course not. Of course you don't. But that's okay, because that's why we have the study guide. Now, we can pick whether we want to work with equation, I don't know if you can see the mouse, whether we want to work with equation 212 or A or B. And honestly, if you look at it, there are less buttons, I think, to push in 212A. So I'm going to put sigma A is equal to sigma X cosine squared theta plus sigma Y times sine squared theta plus 2 tau XY sine theta cosine theta. And then I can write down my tau NT equation, which they didn't give me the same options. It's not really quite as nice. But it's minus quantity sigma X minus sigma Y times sine theta cosine theta plus tau XY cosine squared theta minus sine squared theta. That's really not as nice. I wonder if there's a better a better formula. But yeah, that's it. That is what it is. Hey, let's let's work that. I left that up there while I was writing. Oh, wrong one. So I've got those two equations written down. And now we can start working with them. Well, the first thing I'm going to tell you is, and maybe I should have put this here too, theta is minus 70. I know it's right there, but just to be clear, just to be crystal clear, because this is all I really need for the problem. The big thing here is that's cool because that allows me to just say that's equal to 0 and that's equal to 0. And that makes the problem a whole lot less calculation still. Now, sigma n is equal to sigma x, which I can start putting in my numbers, cosine squared, and my angle is minus 140. Oh, no, sorry. I don't double. This isn't my double angle formula. This is cosine squared of minus 70 plus 125 sine squared of minus 70. And if I calculate that all out, that is going to give me 98.5, and my answer is in megapascals, but I dropped the megapascal. So this is, you can have that or not, whether you want to think psi. Maybe I should have put a note, all units in megapascals. Or degrees. I guess I have degrees here. Wow. Ugh. That's why we got to track units. And then I can also go back and I can go shear NT is equal to, and I calculate that out. I just punch that in, and I'm going to get the answer 9.6 megapascals. And if you think about that, if that's 70 degrees, that's not drawn quite right. This is drawn a little closer. I shouldn't, if that plane, if that normal is so close to this, and this is a principal axis with 0, I haven't gone that far that I should really add a lot of shear stress. And that makes sense to me because I'm a more circle guy. I get more circle. More circle is going to be maximum at the 45, like this, and I'm not there. I'm very close to, it doesn't look like it, but this is 20 degrees, and this angle here, well, that's going to be 25 degrees. So, I got a little bit there, but all right, that's 246. Be well.